Hi, I'm Alex, and today we're going to do an acid-catalyzed hydrolysis of ethyl benzoate. And so at first, when we're looking at this is your ethyl benzoate molecule, and this is your catalyst, which will be regenerated at the end of your mechanism along with your final product. So as the first step, your catalyst attacks your carbonyl molecule here. So the oxygen attacks and takes one of the hydrogens from your catalyst, which then make sure you always draw in the arrows of the hydrogen going back, giving its electrons to the oxygen to make sure that the molecule is still stable. And so from there we go into drawing the resonance forms of these. You always want to keep brackets in there because you have to make sure that you are demonstrating that what you're drawing is an intermediate. And for this, for the remainder of this mechanism, I'm just going to abbreviate the benzyl group as a pH. And this goes, here's your oxygen, now has the hydrogen attached to it, remember, and because of this you do want to put in charges, so this has to have a positive charge. And so then the resonance form of this would be this double bond sharing its electrons with this oxygen to make it a neutral molecule going back up here, but this causes the carbon that's attached to the carbon of the carbonyl group to become positively charged. So now this carbon here has a positive charge on it, and this is just becoming an alcohol group. And from there we want to proceed with the mechanism using the second resonance form that we drew. So we're going to attack the carbon with a water molecule, and the lone pairs on the oxygen immediately attack the positive charge, and this causes the next form of this mechanism to now have a imbalanced water oxygen that is now positively charged as well, that we're going to have to deal with. As this oxygen with the two hydrogens, which is unfavorable for the oxygen, so we're going to have to deal with the hydrogen that one of the hydrogens that's attached to it. And there's this. So then for the next step, we want to get rid of this hydrogen, so we're going to use another water molecule and this oxygen here attacks the hydrogen, and always remember to draw in the arrows here going back to the oxygen to show that it's giving that the hydrogen is leaving its electrons with that oxygen, which then stabilizes it. So then from here you have your next step of the mechanism, which is you're going to have to get rid of you're going to have to make a good leaving group. Right now, this is a bad leaving group, so we're going to have to worry about hydrogenating this ethoxyl group and turn it into a good leaving group to leave the ethyl benzoate intermediate. So to do so, we have to attach a hydrogen to this oxygen here. We want to go back to using our catalyst of H3O+, and this then attacks this oxygen here, attacks one of the hydrogens, and always remember to draw the hydrogen leaving its electrons with the oxygen. So then from this step here, you've now created a good leaving group. So with having this good leaving group, it allows you to then be a little bit more maneuverable with the electrons and the bonds that you can form with the other parts of this molecule. So this now is the hydrogen. So you can take the lone pair that's on, this oxygen here, and it goes down to reform a double bond, which then causes this, which is now a good leaving group, to be kicked off and leave the molecule, which then brings us to our next step. Now a double bond oxygen, which is now, this oxygen, remember, since it's created a double bond, it's now positively charged as well, which then has an alcohol group attached, and now your leaving group is left. So to deal with this unstable or unfavorable oxygen, you have to remove that hydrogen, and to do so, you want to pull off this hydrogen with a water molecule and reform your catalyst that you had in the beginning. So this oxygen then attacks this hydrogen here. Hydrogen always donates its electrons back onto this oxygen, and you create your final product of carbon, double bond oxygen, single bond, right, of your carboxylic acid here with the catalyst of H3O plus. And there you have it. This is the mechanism for acid catalyzed hydrolysis of ethyl benzoate.